Hello everyone, I wanted to provide you with a little bit of a lesson here to talk about our exponent notes. So this is part 2 of our lesson here. So we're going to go over this together. This is a continuation from part 1 that you looked at the other day. So now you're going to be looking at part 2. So now as we continue on, there's a few things I want you to recall. So remember, when we are multiplying powers with the exact same base, we are going to make sure that our base stays the same and that we add our exponents. So for this case, we have our exponents, so we're going to add them up. For when we divide our powers with the exact same base, what we're going to do, we're going to subtract. So for example here, we have a as our common base, and it's going to be m minus n. And then when you raise a power to a power, the base stays the exact same, and you multiply your exponents. So in this case, our base is the same, obviously, and it is outside of the brackets. We have a power, and inside the brackets we have a power, so we multiply them together. Now we're going to look at something called zero exponents. In zero exponents, we have a base and it's a power to 0. That is what that means. So we have an original expression here. Our bases are the exact same. We have 2 to the power of 3 divided by 2 to the power of 3. Our exponents and our bases are the exact same. So if we're to look at this in expanded form, we would write this out just like we did in our part 1 of the lesson. But if we were to subtract them, because we are dividing, we have to subtract our exponents, we would see that we have no bases left. So our simplified expression would be 2 to the power of 3 minus 3 because they were dividing, and we would be left with a power of 0, which is our zero exponents. To write this in standard form, our answer would be 1. Okay? To show this, the reason for that, because it's 2 to the power of 3 over 2 to the power of 3, if we put this into our calculator, it would be equal to 1. Same thing with the bottom answer here. In our expanded form, it's 3 times 3, 5 times over both sides, top and bottom. And if we were to cross them out, we would know that we would be left with 3, 5 minus 5, to be 3 to the power of 0. Our answer in standard form would be 1. So this you can tell that when we look at any sort of base that is raised to a power of 0, it will always be equal to 1. So b to the power of 0 would be equal to 1. It would not be equal to 0. Even though it's to a power of 0, that doesn't mean the answer is 0. It's always to the answer of 1. Okay? Now we're going to look at negative exponents. So negative exponents is something we haven't looked at yet. This is what happens when we are usually dividing our fractions. So in this case here, we have our first example, 2 to the power of 3 divided by 2 to the power of 7. So if we were to write this in our simplified expression, it would be 2 to the power of 3 minus 7 because we are subtracting because it's division. And what would we get? 3 minus 7 would be 2 to the power of negative 4. If we were to write this out in expanded form as seen there, we would cross them off to determine how many we have left. And here we can see that we have 4 2's left. So therefore, a simplified expression with a positive exponent, if you wanted to make this into a positive exponent, we make it into a fraction. Okay? The reason for that is we wanted to make it into a reciprocal. So in this case, it would be 1 over 2 to the power of 4 because there were 4 2's left on our bottom base. If we were to expand that and make it into a decimal format, okay, this would be if we put this into decimal format, we'd get 0.0625, okay? And to make this into a positive number, we times that by 100 to get it into a decimal format, and it'd be equal to 6.25, okay? Now to go into standard form, we should know how to do this from our previous lessons. It would be 1/16, okay? So make sure we know how to go from our simplified expression, okay, into our standard form. So now, if we take a look at our simplified expression and our standard form, 6.25 is the exact same answer as 1/16. So now, let's look at the next example below. We have 3 to the power of 5 divided by 3 to the power of 8. That is subtraction. So our base is the same. We have 5 minus 8, and that will give us -3. So now we would write this in our expanded form. We have 5 threes at the top, and our denominator is 8 threes. So now, in order to know what our simplified expression would be in a positive exponent, we just have to cross all these out and see how many we have left. So we can see here we have 3 threes left, so therefore our positive exponent would be 1/3 to the power of 3. And if we were to write this in standard format, it would be 1/27. And last but not least, we have to the power of 5 and to the power of 6. So therefore, 6 to the power of -1, same sort of thing. And we have to cross some all out. And we would know we have 1 left. So therefore, our answer would be 1/6 to the power of 1, which is also answered in our standard form as 1/6. So we can see here that this is, when we look at our negative exponents, they are reciprocals, okay? So whenever we have a negative number here, we have a negative exponent, what we have to do is we need to make it into a negative reciprocal, which is 1/ax in this case. And this is our positive reciprocal, okay? So whenever we see a negative exponent, we always need to make it into its positive form. If you have any questions, as always, please let me know or pause here to go back if you need to look at anything. As we continue on, we're looking at our positive exponents versus our negative exponents. So in order to evaluate a power with our negative exponent, we always, as I mentioned, rewrite the power as a reciprocal in order to evaluate it as a positive exponent, okay? So this is the formula that we use when we want to have a negative exponent and we make it into a positive exponent, okay? So there you can see we have our positive exponent. We have 4 to the power of 3, which is equal to 64. And if we were to write that into the negative exponent, which is 4 to the power of -3, we would write the reciprocal of it as 1/64. So now let's look at negative exponents with fractions. So when you have a fraction with a negative exponent, we're going to just flip the fraction. So we make it a reciprocal and then make the exponent positive. So here we have 1/5. Always have our fractions in brackets to the power of -2. So what we're going to do, keep it in brackets, we're going to have 5/1. And we change our exponent to now a +2. And if we were to just rewrite this, it'd be 5 to the power of 2. Now we answer our form, or we have our answer our standard form. 5 to the power of 2, so 5 times 5 is 25. Same thing for the next one. We have 2/3 to the power of -3. We flip it, we have 3/2. We make the exponent now positive. And in this case, because it's not over 1, we have to make sure what we do to the top, we do to the bottom. So it's going to be 3 to the power of 3 and 2 to the power of 3. So this will leave as a fraction. So 3 to the power of 3 is 27. 2 to the power of 3 is 8. Okay. Last but not least, we take our fraction, we flip it. So it's 3 over 4 to the power of 1, which is equal to 3 to the power of 1 and 4 to the power of 1, because remember our bases weren't 1, so we had to make sure that we keep it in a fraction. 3 to the power of 1 is 3 and 4 to the power of 1 is 4, so we keep it like that. Whenever we answered in standard form, always make sure that it is in its lowest form, so always check. Is 27 over 8 in its lowest form? Is there a number that can be divided out by it? No, so we are in its lowest form. Now, let's try some examples, and I'm going to get you to try some out on your own and a little bit as well. So, I want you to try B out here on your own and C on your own as well. So, for example, A, we have 9 to the power of negative 2. Remember, when 9 is on its own, it's still always in a fraction, which is over 1. So therefore, when we flip it, it's 1 over 9 to the power of 2. Okay? So what we have to do, because the negative 2 is with the 9, we keep it with the 2. Same sort of thing here for B. Our exponent is negative, so we're not going to keep the whole thing over 1. It's only going to be what the exponent is associated with is going to be over 1. So we're going to keep it as 10.3 times 1 over 9.2 to the power of 6. Okay, you may keep this in brackets. And then we have to do what we do to the bottom, we do to the top. So what we have to do is we're going to put it into a fraction because 10.3 times 1 is just 10.3. And then our bottom is going to be 9.2 to the power of 6. That is in its lowest form. Now try C out on your own, okay? Give you a little hint. It's going to be over 1. So pause the video now, try it out, and see what you can do. All right, so as I mentioned the hint, it's over 1. So now we have to flip it. It's going to be 1 over, and in brackets 1.0, oops, I'm giving you the answer already. 1 plus 0.23 to the power of 2. Now we keep whatever's in the brackets and we add them together, so our answer is going to be 1.23 to the power of 2. Now for example 2, this is when we have our exponents to the power of 0. So 100 to the power of 0 is going to be 1. I want you to try to pause this now and put this into your calculator. What is our answer? So our answer, 12.42 to the power of 0 is always 1. We always knew that. And then now see, this is a tricky one. So we have 8.2 and then in another bracket, negative 1.3 to the power of 0. What we do is we solve our exponents first because of bed mass. So we keep our 8.2 in a bracket, and then negative 1.3 to the power of 0 is always 1. So we multiply the two, 8.2 times 1 gives us 8.2. So I want you to make sure you understand that. If you have any questions, let me know. Please make sure you go onto Math Space now to complete the work that is attached there.